The world may be moving towards renewable energy sources, but fossil fuels are still the fuel of choice for the transportation industry. Especially when it comes to moving big things like planes and cargo ships, it's all about petroleum. But Swiss researchers are looking to at least make the creation of fuel a carbon-neutral process. Kevin Enochs reports.
On the roof of the Swiss Technology College ETH Zurich, researchers are using solar energy to make the petroleum products that run the transportation industry.
In the solar reactor, we have a thermochemical process taking place, splitting water and CO2 and produces syngas. This reaction is highly endothermic, requires very high temperature, and we are providing this energy by concentrating solar radiation by a factor of 3,000.
Aldo Steinfeld from ETH Zurich and his partners say the syngas produced by this mini refinery can then be easily processed into all kinds of fuels.
This is an example of an end product, methanol. We can also process syngas to other liquid hydrocarbon fuels, such as gasoline or kerosene.
So what's the point of using a clean solar refinery to make the dirty fuels that are driving climate change? Steinfeld says their process won't make fossil fuels clean, but at least make sure they don't do any damage.
These fuels are carbon neutral. Their combustion releases exactly as much CO2 as we originally extracted from the air for the air production.
The process basically creates fossil fuels that don't add any planet-warming carbon dioxide to the atmosphere. Philip Furler from the company's spin-off Synhelion says the team has set the ambitious goal of expanding this process to create fuel on an industrial scale.
Our goal is that by 2025 to have the first full-scale commercial solar fuels plant in operation with a production capacity of around 10 million liters of methanol per year.
That sounds like a lot, but keep in mind the U.S. alone burned an estimated 1.4 billion liters of gasoline in 2018. But in a rapidly warming world, every little bit helps.